So, hi, today we're going to be solving Cambridge IGCSE Chemistry Paper 4 Theory Extended May June 2025 and Paper 42. Okay, so this was a paper that was tested recently in May June 2025, and we're going to be solving it. And please don't worry if you don't get anything right or if you've messed up with the paper, it's fine. Inshallah, all of you are going to get good results. The results aren't out yet, but still, don't worry, it's going to be fine. So let's get started with the paper. It says that using numbers only, state the percentage of nitrogen in clean dry air. Okay, the first thing I'd like to tell you guys over here, when they say that you have to use numbers only, this means that you don't have to use a percentage sign or a degree Celsius sign or any kind of signs. You just have to work by using numbers. Okay, percentage of nitrogen in clean dry air, I guess that's undisputable answer. That's going to be 78%. If they were asking about oxygen, it was 21%, and if they were asking about carbon dioxide, it's 0.04%. so the answer is obviously going to be 78%. Okay, that was easy. Typical operating temperature of the contact process in degrees Celsius. Contact process is a process by which we turn sulfur dioxide to sulfur trioxide by oxidizing it using oxygen. Okay, and the temperature that we use is 450 degrees Celsius, and the pressure that we use is 2 atm, and the catalyst we use is vanadium Vi oxide, okay, or vanadium 5 oxide. Next question says number of metals in period 3 of the periodic table. I see many people confusing this part because they don't find firstly the periods, and secondly they don't distinguish between the metals and the non-metals. Okay, so there's a very easy trick for that. First you have to start your first period with this hydrogen. They miss out the hydrogen. Most people think the first period is this lithium one. That's completely incorrect. That's not correct. The first period is this, the hydrogen one. Okay, this one is your period number 1. You have to keep this in mind. Period number 2 is this one with the lithium one, and the period number 3 is this sodium one. So period 3, we have to find the number of metals in it. Once we figured out the correct period, now let's figure out the metals in it. Okay, many people thought that in the exam silicon is a metal or phosphorus is a metal. No, bache. What you have to look for is this zigzag line. What is this zigzag line? The zigzag line on the periodic table, which is not given in the Cambridge periodic tables. Okay, the periodic table that you get for OLevels or IGCSE examination does not have this zigzag line. You have to figure it out yourself, and many people, they fail to figure it out. You had to look for this line, okay, that separates the metals from non-metals. On the right side we have metals, on the left side we have the non-metals. All the metals that are in period 3: sodium first metal, magnesium second metal, and aluminum third metal. Silicon is not a metal. Why not a metal? Because it's on the left side of this zigzag line, so we cannot include it in the metal part. So we only have 3 metals. Okay, so the correct answer is going to be 3. Okay, the next question which says that number of halogens which are gases at RTP. So what does RTP means? RTP means room temperature and pressure. Okay, room temperature and pressure. Okay, we have to find the number of halogen which are gases. First, let's figure out what are halogens, where are halogens. Okay, halogen is basically this group 7. Okay, this is the halogen group. Okay, so let's just highlight this halogen group over here. There's fluorine, chlorine, bromine, iodine, and acetylene. Okay, these are on halogens. Now we have to figure out the number of halogens that are gases. Okay, I know that fluorine is kind of a yellow kind of a gas. Chlorine is a greenish yellow gas. It's a bit darker than fluorine, but it's still a gas. Then we come to bromine. Bromine is a red brown liquid. Okay, so bromine is not a gas, it's a liquid. Iodine is a gray black solid, and same goes for acetylene. It's also a solid, because as you descend down group 7, what happens is that your density increases. So we are seeing that the first 2 are gases, then comes liquid, and then comes solid. So as you're descending group 7, what's happening is that their physical states are changing. They're turning from gases to liquid to solid. So the first 2 members are gases. So the number of halogens that are gases are 2. Okay, typical temperature for the fermentation of aqueous glucose in degrees Celsius. Okay, many people are confused with this, that what's the temperature? Some say it's 30, some say it's 37, some say it's 25. Okay, you don't have to get confused. You just had to refer to the syllabus. You should know the syllabus by heart. In the syllabus is clearly mentioned. This is the Cambridge IGCSE syllabus, for for 2023 to 2025, okay? And the syllabus clearly mentions, it's highlighted that describe the manufacture of ethanol by fermentation of aqueous glucose at 25 to 35 degrees Celsius in the presence of yeast and absence of oxygen, okay? These are the conditions, and the temperature was 25 to 35. So any temperatures in between, I guess they should have, made it correct, because that should technically be correct. If you even have written 30 or anything else, I'm not sure about it, but the temperature that's typical temperature is 25 to 35, okay? So we're gonna write 25 to 35, or you can only write 30 degrees Celsius as well. That's also correct, I guess. That should be correct because that's exactly in between two. Okay, number of unbranched structural isomers of C4H8 which decolorize aqueous bromine. Okay, now there are two parts to it. Firstly, we have to find the number of unbranched isomers of C4H8, and second thing that we have to be careful about is it should decolorize aqueous bromine. That means that it should not be an alkane, it should be an alkene. Okay, now let's draw the number of unbranched isomers of C4H8. Okay, the first isomer which I can think of is simple, C4H8. 1, 2, 3, 4, and my 8 hydrogens attached to it. Okay, that's but-1-ene. Why but-1-ene? Because my double bond's on the first carbon, okay? The double bond is on the first carbon, okay? Second, either I can branch it to make an isomer out of it, or I can just move the position of the functional group to over here to make but-2-ene. That's going to be an isomer of but-1-ene, okay? So here I go with my but-2-ene. So this one right here is my but-2-ene, and that's an isomer of my but-1-ene. So these are both C4H8, okay? These both have the formula of C4H8. Now, what if I tell you that I can make one other thing that is unbranched and that has the formula of C4H8? Let me draw it for you. That's a cycloalkane, okay? That's going to be a cycloalkane, which is going to be something like this. Hydrogen, 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 and hydrogen. Count the hydrogens and count the carbons. This is C4H8 and this is cyclobutane. This is an alkane and this has the formula for C4H8. There are 4 carbons in there, 8 hydrogens in total, okay? Just count them and you're going to find 8 hydrogens and 4 carbons, okay? So now I have 3 unbranched, isomers that have the formula C4H8. Now one other thing, that if you try to make one more, like you try to make but-3-ene or but-4-ene, that's not going to be possible, because if you move this functional group further to this side, that's again going to become but-1-ene. Why? Because this time I'm going to start the counting from the right. This is going to be my first carbon, this is going to be the second, this is going to be the second, this one's going to be the third. So it's again going to become but-1-ene. I hope you get this thing, okay? That these are the only 2 possible unbranched isomers right now of butene. Now if I start branching, okay, though the question does not mention, but if I start branching, then what I'm going to do, I'm going to do this thing. I can do this thing, or I can make a lot of other things as well, but I'm not going to do this thing because the question clearly says I need unbranched isomers, okay? Now I technically have 3 isomers, okay, which I found 1, 3 and 2, okay? I can just name them like this. I have 3 isomers, but the other part of the question is also very important. I found 3 unbranched isomers, structural isomers of C4H8. The other part is which decolorize aqueous bromine. Unfortunately, the cycloalkane cannot decolorize aqueous bromine. Only but-1-ene and 2-ene can decolorize. Why? Because only this double bond can decolorize aqueous bromine from orange to colorless. Only this double bond. If you don't have a double bond, you cannot decolorize aqueous bromine. And unfortunately, the cycloalkane, which you're going to study in A-levels, though having the molecular formula of C4H8, is not going to be included in this question because it cannot decolorize aqueous bromine because of lack of a double bond. It does not have a double bond. So the answer is that we only have 2 unbranched structural isomers that can decolorize aqueous bromine with the formula of C4H8. Okay, number of covalent bonds in one molecule of ethanol. Okay, that's going to be a good question. So let's, we have to draw ethanol. To figure it out, we have to draw a full displayed formula of ethanol if we want to figure this out. Okay, the formula for ethanol is quite simple, C2H5 OH, okay? Now let's draw all the bonds. There's going to be a carbon like this, a hydrogens like this. We just have to count the number of covalent bonds. Okay, this is my first covalent bond, second bond, third bond, fourth bond, fifth bond, sixth bond, seventh bond, and eighth bond. I guess there was no rocket science in it, just had to count the number of these lines in the displayed formula. That comes out to be 8 if I'm not wrong. 1 2 3 4 5 6 7 8. So the correct answer for this one's going to be 8. Okay, moving on. Number of carbon atoms in one molecule of propyl butanoate. I guess there's no brain in it. It's going to be 7. Propyl means 3. Butanoate, butane means 4. 4 plus 3 makes it 7. But if still you're confused, no worries. Sometimes it takes time to, understand things. You just draw propyl butanoate. Propyl means 3 carbon alcohol, something like this. Okay. And there's going to be an O. And butanoate means a 4 carbon acid, something like this. Okay, done. Now just count the number of carbon atoms. 1 2 3 4 5 6 7. Okay, so these were all the answers to the first question, and that was how you had to solve it. I hope you understood it. Moving on. This question is about covalent compounds. Okay, state what is meant by a covalent bond. Okay, many people don't get why this question is of 2 marks, because many people think that you just have to write about the sharing of electrons between 2 atoms, but that's not it. I always prefer, I have always said in my previous videos as well, that it's very good that you have a strong grip on the syllabus, because all these questions, that what is meant by and state, they are directly from the syllabus, and you just have to write the syllabus definition. You have to learn it. So if I just move on to the syllabus, which is here, it says that a covalent bond is formed when a pair of electrons shared between 2 atoms, leading to a noble gas electronic configuration. You just had to write this exact definition in order to get your 2 marks. First was the sharing of electrons, and the second was the noble gas electronic configuration. That was exactly what you had to do in order to gain that 2 marks. Okay, so it's formed when a pair of electrons is shared between 2 atoms, leading to noble gas electronic configuration. It was important because it was of 2 marks. So to get these 2 marks, so you had to write that it is, sharing pair of electrons between 2 atoms leading to noble gas electronic configuration. This part just gives you 1 mark. Noble gas electronic configuration. So here is a breakdown of your 2 marks. Okay, next, another 2 mark question which many people confused. They didn't know why is it of 2 marks. There's again something in it that you have to realize, that chlorine ioxide. Okay, chlorine ioxide is a simple molecule with covalent bonds. Okay, state what is meant by this I thing in chlorine oxide. Okay, that's very simple, that you have to realize that whenever chlorine is with oxygen, you should know its oxidation number is a positive 1. I know many people don't know this, but always when chlorine is with oxygen, the oxidation number of chlorine is a +1. Okay, so right now the oxidation number of chlorine is a +1, and because you have 2 chlorine, so together it's going to be a +2, and to balance out a +2, you basically have a -2 on oxygen. So that's how this thing is working. So this 1 in chlorine, the chlorine 1 oxide, this 1 basically tells the oxidation number of chlorine, which is a +1. So just by writing that it tells about the oxidation number of chlorine, that's going to be wrong. You have to write which is +1, because you have 2 marks. So 1 mark for it. This 1 basically tells us about the oxidation number of chlorine. That's going to be your first mark, and the second mark is going to be which is a +1. Okay, you had to realize this and you had to figure it out. I know this one's tricky because chlorine is a halogen, always have a -1, but when it's with oxygen, you had to know it had a +1 oxidation number. Okay, Moving on, complete the dot and cross diagram in figure 2.1 of a molecule of chlorine dioxide. Show the outer electrons only. Okay, we just don't have to do anything inside. We just have to make a single bond over here. You also had to realize one other thing, that oxygen only make 2 bonds. Okay, 2 bonds, because oxygen is in group 6. How many electrons it needs to get a full outer shell? Only 2. So to get 8, so it's only going to make 2 single bonds with chlorine, and chlorine being group 7 only needs 1. So 1 bond over here, 1 bond over here. Now, why is this question also carrying 2 marks? The reason for that is that you had to draw the lone pair of electrons as well. Many people miss out the other electrons, the unbonded one. They only draw the bonded electrons. No, you have to draw the lone pair as well. Okay, so we're going to have 6 lone pairs over here. 1, 2, 3, 4, 5, 6. 6 lone pairs over here. Lone pair mean the unbonded ones, and 1, 2, and 3, 4. 2 pairs over here. Okay, I meant 3 pairs, but in total we have 6 electrons. So done with it. Moving on, explain in terms of structure and bonding why Cl2O boils at a lower temperature and does not thermally decompose into its constituent elements chlorine and oxygen. Okay, this is a very tricky question, but in order to attempt this question, I guess the concept of the covalent bonding is very important. You had to realize that when you have Cl2O, what's basically you are dealing with is something like this. This is 1 oxygen, 2 chlorines. Okay, that is Cl2O. Okay, 1 oxygen, 2 chlorines. Again, 1 oxygen, 2 chlorines. You have a sample of this thing, 1 oxygen and 2 chlorines. When you're boiling it, what you're trying to do is, okay, this is the chlorine, this small thing, and the big one is oxygen. Okay, just for the reference, I've drawn it like this. Now you have to realize that when you are boiling it, okay, when you are boiling it, what you're doing is you're not breaking this bond. Okay, this bond between chlorine and oxygen is a covalent bond, and you cannot break a covalent bond by low temperature, because over here they've written that it only requires a low temperature to boil it. So you only need a low temperature to break this, the force of attraction between this molecule and this molecule. So when you're boiling it, you're not breaking this covalent bond. What you're breaking is the force of attraction between 2 molecules. That's why it has a low boiling point, and it does not separate into chlorine and oxygen because you're not breaking the covalent bond. What you're breaking is this, the attraction between these two, the attraction between these two. That's being broken. That's weak attraction. But the attraction of the covalent bond over here, this covalent bond right here, this is very strong. That is why it does not separate or decompose into chlorine and oxygen, because this is still unbroken. So that is what you have to write. Explain in terms of structure. Structure is going to be, you have to write that it had a simple molecular structure. Okay, and why it boils at a low temperature, having weak intermolecular forces. Okay, I'm just breaking down 3 marks. 1 marks for this structure, 2nd mark for weak intermolecular forces of attraction, molecular forces of attraction, and the 3rd mark over here was that why it does not, the important part, why it does not decompose into constituent chlorine oxygen was because weak covalent bonds, I'm just not writing it into a paragraph form. I'm just telling you about it according to the marks. 1st mark for this thing, this point, 2nd mark for this weak intermolecular force, and 3rd mark for not a weak, a strong covalent bond, okay, between chlorine and oxygen. Okay, so that's a breakdown of the entire question. I hope you get it. Okay, give 2 reasons why liquid Cl2O is a poor conductor of electricity. Okay, why is something a poor electrical conductor? What conducts electricity is either the mobile electrons. Okay, either you have mobile electrons, which is in case of metals, or if something has mobile ions, in case of graphite or ionic compounds when melted in an aqueous solution. So it has no mobile electrons to conduct electricity and no mobile ions. That is why it is a poor conductor. So these are the only 2 reasons that I can think of. I hope you get it. Moving on to the next question. Okay, so the next part says that carbon and silicon IV oxide both exist as giant covalent structures. Okay, that's what we know. By carbon, they simply mean your graphite, and your diamond. So graphite and diamond are basically allotropes. Allotropes means that they're both made up of the same element, which is carbon, but they exist in different physical forms, okay? Because the arrangement is of graphite and diamond are completely different. I hope you're aware with this fact. Graphite basically exists as hexagonal rings, something like this, and it is a layered structure, whereas diamond, it is a three-dimensional tetrahedral structure, okay? So there's a difference. Okay, name a giant covalent structure of carbon which conducts electricity. I guess that's easy because there are only 3 structures in your syllabus that are giant covalent. There's silicon IV oxide and there's carbon, which includes your diamond and graphite. And out of diamond and graphite, which conducts electricity, is only graphite. So a giant covalent structure that's gonna conduct electricity is your graphite. Okay, next, identify the particles responsible for the conduction of electricity in this covalent structure of carbon. Okay, until now, what we guys have learned until in O levels is that only 2 particles are responsible for conduction of electricity. Either you have free mobile ions or you have free mobile delocalized electrons, okay? Only these 2 particles can conduct your electricity in any kind of structure, okay? In ionic compounds, you have your ions. In metals and in graphite, you have your electrons, okay? In graphite, you don't have any kind of ions, okay? There's not even a possibility of ion formation in graphite because you can't have ions. You have covalent bonds, carbon atoms connected to each other by covalent bonds, and each carbon atom is connected to 3 other carbon atoms, okay? If this is my 1 carbon atom, in graphite, it's going to be connected to 3 other carbon atoms, something like this. So the 4th unbonded electron, because you know that in the outer shell of carbon, we have 4 electrons. Okay, one has made a covalent bond here, one has made a covalent bond here, one has made a covalent bond here. So we have a 4th unbonded electron, and this 4th unbonded electron in the structure of graphite is capable of moving through the layers of graphite to conduct electricity because it is delocalized, okay? It is unbonded, so it can conduct electricity. So the particle that's responsible, because they're asking for the particle, is your electron, or you can write the delocalized electron, okay? But electron is going to give you this 1 mark. Okay, silicon IV oxide contains silicon atoms, okay? Contains silicon atoms, Si, and oxygen atoms, okay? You should know this, that obviously it's silicon IV oxide. It's going to have silicon and oxygen. Figure 2.2 shows part of a giant covalent structure of silicon IV oxide, okay? Complete the diagram in figure 2.2 by adding this symbol for each of the 9 atoms shown. Figure 2.2 diagram is shown here. Okay, that's going to be interesting. Now, a little bit of your concept testing is going to be done over here. Originally, on the exam paper, the diagram was almost the same. I just tried to replicate it as good as I can do. And now you just had to understand one thing. Silicon and oxygen. Okay. Silicon IV oxide, it's not silicon dioxide. It's simple SiO2, okay? SiO2. Now, originally, what it was originally was Si2 and O4, okay? I'm telling you about the original thing. What this meant was that each silicon atom is basically connected to, look over here, if I just try to show you like this, that, okay, I'm going to explain it to you by using a periodic table. I guess that might help. That each oxygen atom is connected to 2 silicon atoms, okay? Each oxygen connected to 2 silicon. And in turn, each silicon connected to 4 oxygens, okay? What this 2 and 4 tells us, originally it was this, but why it is SiO2, you just cut 2 1 times 2 and 2 2 times 4. So it became Si1 and O2. So that's the empirical formula. And in giant covalent structure, you always have empirical formula. I'll explain this by giving you an example of this. For example, you have diamond, okay? Just try to understand this. You have diamond, okay? I say that in my diamond, okay, I have this diamond, piece of diamond, okay? This is my diamond, and that's a red diamond, and it's made up of carbon. I say that in this diamond, piece of diamond, I have for instance, I know that's hypothetically not correct, but for instance, I say that I have 1,000 atoms of carbon in this diamond. So can I write C1000? This is C1000 because I have 1,000 atoms of carbon in this diamond? No, I cannot. Why can I not? Because in a giant covalent structure, we don't name the things by the number of atoms, okay? But if I have Cl2, something like this is a chlorine molecule, Cl. So I can name it like Cl2, okay? Because this is how chlorine exists. But over here, because this piece has 1,000 atoms, I cannot name it C1000. So for giant covalent structures, you don't write this number with them, okay? This number is just a ratio. This is not the exact number, okay? So this over here, Si2O4, this is just a ratio. This is telling you about the exact ratio. I hope you understand this, that this is a ratio that for every 2 silicon atoms, we have 4 oxygen atoms. So for instance, I say I have 2,000 silicon atoms in this sample, then I'm going to have 4,000 oxygen atoms in this sample, okay? So this is just a ratio. This does not mean that this is going to be an exact number, because for a giant covalent structure, you can't have a simple molecular formula like this. You cannot have Cl2. For methane, you have CH4. Why CH4? Because each molecule of methane looks something like this: 1 carbon and 4 hydrogens. But for a giant covalent structures, Si2O4, it does not mean that you have 1 silicon and 4 oxygens. That's going to be incorrect, okay? So it's just a ratio, okay? So we have to take care of one thing, that 1 silicon has to be connected to 4 oxygens, okay? 1 silicon has to be connected to 4 oxygens, whereas 1 oxygen has to be connected to 2 silicons, okay? So right now over here, if we start from the top, we see one thing, that this atom, whatever this is, it is being connected to 4 of something, okay? It is connected to 4 of something. We know that 1 silicon has to be connected to 4 oxygens. So over here, it has to be a silicon, because 1 silicon is connected to 4 oxygens. If these were like circles as well, it had to be O, O and O, okay? Because we had to connect 1 silicon to 4 oxygens, okay? Now whatever is in the center, okay, I don't know this center thing, but I know one thing, that 1 oxygen has to be connected to 2 silicon, and this right here, this center thing, is making 2 bonds, one upwards and one downwards. So this has to be an oxygen that is connected to 2 silicons, one on the top and one on the bottom. Okay, now this is a silicon. 1 silicon has to be connected to how many oxygens? 4 oxygens. Okay, 1 bond is done. Okay, this bond with 1 oxygen is done. So now we have 3 more bonds, and it had to be 3 oxygens. Okay, now again 1 oxygen had to be connected to 2 silicons. 1 silicon is on the top, 1 silicon is on the bottom. I don't know if you guys found this difficult in exam, but after seeing this, I feel that it might be difficult and challenging for some people who just remembered SiO2. They didn't realize that it was just a ratio, a simplified ratio of Si2O4. This was the entire structure, okay? So you just had to realize this thing, and then again, 1 oxygen connected to 2 silicons. So look, I just found out that it was a bit different from the exam one, because I have the exact paper over here. So you can just see over here, because I couldn't just like exactly copy it. But if I try to, okay, now we are gonna make a silicon again over here, and we have to make 1, 2, 3, 4 bonds. Over here, the exam paper looked something like this. It had to be connected to, again, 1 silicon, which had to have 4 bonds like this, okay? And this also had to be silicon. So I guess it looked something like this, okay? You have to be similar to this one, and you just had to realize one thing, the connections and the bonds, that 1 oxygen had to make 2 bonds and 1 silicon had to make 4 bonds, okay? I hope this one's clear. Okay, moving on to the next one. This question is about electrolysis. Okay, complete the definition of electrolysis by filling the missing words. Okay, over here some words are missing, we have to fill them. The decomposition of dash compounds. Okay, you should know the exact definition of electrolysis from the syllabus. I highly encourage studying the syllabus again and again. It was written in the syllabus that it had to be ionic compounds. You do electrolysis of ionic compounds. You cannot perform electrolysis with a non-polar compound. For example, you cannot do electrolysis of methane. Why can't you do electrolysis of methane? Because there are no ions involved in methane. Methane is a covalent structure. You need ions in order to separate them out, okay? So for electrolysis, you need an ionic compound, Okay, the decomposition of ionic compounds when dash or in dash, okay, when in molten or in aqueous state by passage of an electric current. Because you cannot in a solid state, okay, for example, this is NaCl in a solid state, so all the Na ions and the Cl negative ions, they're all in fixed positions, they cannot move, Na and Cl negative ions. And when your ions cannot move, these ions cannot carry current. If they cannot carry current, no electrolysis can be performed. To perform electrolysis, what you need is, you need mobile ions, you need free ions that can move throughout the structure, okay? I know this is a very basic concept, but over here you must realize that your ions, your ionic compound, it should either be molten or in aqueous state, meaning dissolved in water, if it needs to carry current, if it needs to move throughout the structure. So I guess I don't guess, I am sure about it, when in molten or in aqueous state, okay, by the passage of an electric current. Many of you might think that this is out of syllabus or this is not in the syllabus. For those of you who think something like this, you just have to realize one thing, that you have to be with the syllabus all the time, okay? So let's see the syllabus. I know this is part of the syllabus. Syllabus chemistry. So this is all part of the syllabus. I highly encourage you guys to read the syllabus. I guess more than half of the paper are fill in the blanks from the syllabus. So if you go to electrolysis chapter, this is alloys, transition elements, salts, acid bases, reversible and equilibrium, rates, physical and chemical changes. These are exo, endo. Okay, we have electrolysis over here. Okay, read the first line. Define electrolysis as the decomposition of an ionic compound when molten or in aqueous solution by the passage of electric current. Okay, you've read this definition. Now read this thing. The decomposition of dashed compounds when dash or in dash state by the passage of an electric current. Don't you feel that you just had to read this syllabus given by the Cambridge in a good way? You just had to have a strong grip on the syllabus in order to attempt your paper. It was just to fill in the blanks from the syllabus. So I personally believe that more than books, more than anything, you should have first a strong grip on the syllabus, okay? If any one of you have read the syllabus, it must be a piece of cake for them, okay? Moving on to the next question, okay? Electrolysis of aqueous copper to sulfate is carried out by using the apparatus shown in figure 3.1. The electrodes are made of platinum. Okay, platinum is an inert substance, so you can make your electrodes out of platinum. It won't react with your the products won't react with your electrodes. Obviously, if your electrodes are reactive, then if you form chlorine or any other thing on the electrodes would be reacted, would be used up by the product, okay? So you always need to have inert electrodes, okay? State whether the mass of the cathode increases, decreases, or remains the same when platinum electrodes are used. Okay, the electrode is of platinum, okay? And I just told you that platinum is inert. What do I mean by inert? I mean it is unreactive, okay? So one thing I know for sure, that my electrode won't react, okay? I know this. But I have to keep 2-3 things in mind. I know that my electrode won't be used up. But I have to see one other thing as well. What do I have to see? That what is going to be formed at my cathode and my anode. If I need to know, for example, any kind of metal is being formed at my cathode or my anode, okay? At anode, metals usually don't form. At cathode, metals form, because cathode is the negative electrode and metals are positive ions. They form positive ions. They're electropositive. So they're going to be attracted towards the cathode, which is the negative electrode. Okay, now I need to know one thing. What is that one thing? That either anything is going to be formed at my cathode or my anode or whatever. Okay, so let's just check out the products. Electrolysis of aqueous copper to sulfate. Okay, aqueous means that I have my hydrogen ion, which are H plus ion, and I have my hydroxide ions, which are OH negative, okay? These two ions are present in water. and aqueous just means that I am doing this in water. Okay, now the second thing I need to know is copper sulfate. Copper sulfate is going to have Cu 2 plus ions and SO4 2 negative ions. Okay, now I need to check out which ions are going to go towards the cathode. I know my positive ions, they're going to move towards my cathode, and these are the negative ions, they're going to move towards the anode. Now I have to check that out of the positive ions, because they're talking about the mass of the cathode over here, out of my 2 positive ions which are moving towards the cathode, what is going to be formed at the cathode? Because only one product can be formed over here. Either it's going to be hydrogen or it's going to be copper. Now how to check which ion is going to be discharged at the cathode out of metals? You have to know the reactivity series. So what is the reactivity series? Reactivity series is basically a list of metals which starts with potassium, sodium, calcium, magnesium, aluminum, and it just continues like this. Okay, there like a lot of metals, and then you have your hydrogen. Hydrogen is also included in the reactivity series. Okay, and then you have your copper. In metals, you should know this thing. I hope you guys know, the more below you are in the reactivity series, the more chance you have, not more chance, the more confirmation you have of getting discharged, because the more unreactive you are. And the more unreactive you are, the more easily you can gain those electrons to discharge yourself. Okay, this is potassium. Okay, this is potassium, and this is copper. Okay, now potassium is above in the reactivity series and copper is below in the reactivity series. So what makes a metal above or below in the reactivity series? You might think about it. I'm telling you this one line, and this one line is going to be very important for your O levels, for your A levels as well. The reactivity of a metal, okay, the reactivity of a metal depends on its ability to lose electrons. Okay, depends on its ability to lose electrons. This means that potassium can lose its electrons more readily than copper because it's above. The more above you are in the reactivity series, that means that more readily you can lose electrons. So the reactivity of a metal is determined by its ability to lose electrons. Okay, obviously if potassium can lose electrons more readily, then it would not gain easily. Copper would gain easily because it's less reactive, it's below. I hope you understand this concept, that the below you are, the more easily you can gain, and the above you are, the more easily you can lose. Okay, that means that copper can gain electrons more readily. So copper is going to discharge out of hydrogen and copper is going to discharge at the cathode, which is the negative electrode. Okay, so at the cathode, what's going to be formed? Not hydrogen. Why? Because it's above. What's going to be formed over here? This is your negative electrode, which is going to be a cathode. Let's just label it. This one's our cathode, and over here we're going to form our copper metal. Okay, so state whether the mass of the cathode increases, decreases, or remains the same when platinum electrodes are used. Okay, so it's obviously going to increase. Why it's going to increase? Because copper is a metal. Copper is going to be deposited on the cathode. This is your cathode, negative cathode. Over here you're going to form copper metal. This is not the exact color of the copper metal, I'm sorry for this, but you're going to form it something like this. Around your cathode it's going to be deposited, so it definitely increases. Okay, describe the change in appearance if any of the electrolyte in the electrolyte, okay, when platinum electrodes are used. Okay, now I want to tell you something. I hope you guys know it, that copper sulfate is initially in which color? Copper sulfate is a blue color solution. Okay, you should know this, that copper sulfate is a blue color solution, and the blue color of this solution is because of this copper ions. Copper 2 plus ions are blue in color. So because of these copper ions, you should know that copper is a transition element, and transition elements form colored compounds, and because it's blue in color, that's why your copper sulfate, which is going to be over here, it's all going to be blue in color. Okay, this is going to be blue in color. But what's happening during the electrolysis? They're asking about if there's going to be any change in the appearance. There's definitely going to be a change, because what's happening is that your copper is coming out of the solution and is being deposited on this cathode. Okay, on this cathode your copper is being deposited. Your Cu 2 plus ions, okay? From the solution, they're being deposited on your cathode. That means the Cu2 plus ions are being reduced in the solution. In the solution, their quantity is being reduced because that's being deposited on the cathode. So what's going to happen is that the color is going to fade away, because the color was because of copper, and when copper is being lost from the solution, it's going away, the color fades away. Okay, so describe the change in appearance of the electrolyte. Electrolyte is basically your solution, okay, this solution right here, which is Cu2 plus and SO4, 2 negative ions with your hydrogen and hydroxide ions. This all is your electrolyte. So the color fades away, or it, you can say, disappears or whatever. So the blue color fades away, or you can say it turns colorless or whatever, okay? Fades away or turns colorless. The idea is that it will simply just, fade down. It won't be as blue. Why? Because the copper is being lost. Okay, describe what is seen at the anode when platinum electrodes are used. Okay, we have to write about the observation of the anode, and that's of 1 mark. So what's being formed at the anode? You had to realize this thing, that your sulfate ions won't discharge, because at the anode, because your anode is positive, the negative ions are going to be attracted towards the anode, and out of these 2 negative ions, which ion is going to be formed at the anode? The sulfates won't discharge, so it's going to be hydroxide. Okay, so hydroxide had to discharge on the anode, and now when hydroxide discharges, you know that oxygen is formed. So you have to write what is seen. You don't have to write, if you just write oxygen is formed, this is incorrect, because you're not addressing the question properly about what is seen at the anode. You have to be careful about the observations. You write exactly what you see. So you had to write, what I'm going to see is bubbles. Oxygen is a colorless gas, so bubbles of a colorless, or you can write odorless gas is seen. Okay, that is your observation. Write about the ionic half equation for the reaction at the anode. So what kind of thing is being discharged at the anode? Hydroxide. And you know the equation for hydroxide ions. It's a bit tricky equation, but it's 4OH negative forms O2 plus 2H2O. You have to learn this equation, okay? Plus 4 electrons, okay? This one's your equation. You had to learn as it is, and you have to imprint this equation as it is on the exam paper. Okay, done with this? Moving on. The electrolysis is repeated using copper electrodes. Okay, now we are using copper electrodes, and you know that when we use copper electrodes, the electrodes react. Previously, we were using platinum electrodes, and while using platinum electrodes, what was happening was that out of the electrolyte, ions were coming and being deposited. But when we use copper electrodes, the electrodes are going to react. Electrodes anode is going to lose mass, it's going to dissolve, and cathode is going to gain mass, because copper is going to be deposited at the cathode. State whether the mass of the cathode increases, decreases, remains the same. It's obviously going to increase. It increases. Again, why it increases? Because look, what's happening at the anode and the cathode? Let me explain it to you over here. By the way, if you've given your exam, you should know this thing, that look, this is your anode, this is your cathode, this is your electrolyte. Okay, this one's gonna be positive, this one's gonna be negative, this one's your electrolyte. So what's happening is, this is made up of copper, okay, this is made up of copper. Over here at your anode, okay, this one's your anode. What's happening is that copper is being dissolved. So the equation for the anode is going to be, you have copper, which forms ions Cu2 plus 2 electrons, okay? And these ions out of the anode come into the solution, Cu2 plus ions. And now what happens is that these ions on the cathode, Cu2 plus ions from the solution, they gain 2 electrons plus 2 electrons to form copper. And when they form copper, this copper is going to be deposited around the cathode, something like this. And when copper is deposited around the cathode, it's going to gain mass. So the mass increases. Describe the change in appearance, if any, of the electrolyte when copper electrodes are used. What's happening is, earlier what was happening was that copper was being coming out of the solution, so the color faded away. Over here, do you remember, blue color fades away or turns colorless. Why? Because copper was coming out of the solution and no copper was coming in, only it was going out. Okay, but over here, look, what's happening is the amount of copper that comes out of the solution, something like this, the same amount goes into the solution as well from this anode that is being dissolved. For example, think about this, that the same amount, okay, for example, you have a sack of rice, okay, you have this sack or whatever you call it of rice. You take two bowls of rice out of it. The same 2 bowls you add again in that sack. Will the amount of rice in the sack change? No, because the amount that you're taking out, the amount of rice that you're taking out, the same amount of rice you're adding in back. So the net amount of rice does not change. It remains the same. Though you've taken out, but you've replaced it with the other 2 bowls. Do you understand this? But previously what was happening is, they can either the other amount of rice, they're coming from this anode, okay? They're coming back into the solution. But earlier, you were taking out 2 bowls, you were taking out copper ions, but you were not putting them back into the solution, so the color faded away. But over here, the color of the electrolyte, it's gonna remain the same. So it remains same. Why it remains same? Because you're replacing it with the anode is gonna react and it's gonna be replaced. Okay. Aluminum is extracted from its purified ore by electrolysis. The bauxite is the name of the ore. Okay, name the ore of aluminum. Bauxite. Okay. And for what type of material you use cryolite. Okay. And for iron, what is the name of the ore of the iron? Hematite. Okay. These are just simple substances. Name the substance added to this process to reduce the operating temperature. Obviously, it's going to be cryolite. I hope you guys know this, that we add cryolite. Cryolite, what it does, it basically dissolves this bauxite ore and it reduces the operating temperature, because to melt this bauxite ore you need extremely high temperatures, above 2000 degrees, almost till 2000 degrees you need or above. So in order to reduce the temperature, you add cryolite to it so you can perform this electrolysis at a lower temperature. Okay, explain why the anodes need to be continually replaced during this process. Why they need to be replaced? Because what's happening, you have aluminum ore. Aluminum ore is Al2O3. This is your bauxite ore. Out of this bauxite ore, at the anode, why anodes need to be replaced at the anode? What is the product? The product is oxygen. Okay, so what's going to happen is that your oxygen O2 negative ions, basically they're going to lose electrons to form O2 plus 2 electrons. Okay, and over here you put a 2, so over here you put a 4. Okay, I hope you understand this equation. Okay, now you have your oxygen being formed. Your anode is made up of, in this electrolysis, the anodes you use, they are basically made up of graphite. Okay, and graphite is simply carbon, so the anodes you're using are carbon anodes. Okay, so what's happened is that the oxygen that's being formed at the anode, it reacts with carbon. This oxygen reacts with carbon to form carbon dioxide. That's why the anode that's made up of carbon is used up. So we're gonna write that the oxygen formed at anode reacts with the carbon anodes to form carbon dioxide. Hence, the anode is used up or eaten, or it kind of gets eaten away, whatever, used up. Hence it needs to be just replaced regularly. I guess that's enough. That's simple. You just had to tell this thing, okay, that the oxygen is gonna, you can write equations as well, is gonna form this carbon dioxide. Okay, moving on. Chromium is the element with atomic number 24 in the periodic table. Okay, why do you guys think that this information is given to you? This is simply given to you so you can check out the position of chromium in the periodic table. That's going to help you, because 24 easily tells you that where you have to go. It pinpoints the location of chromium, because atomic number is something that's different for every atom in the periodic table. Every atom in the periodic table has a different atomic number. No two atoms can have same atomic number unless they belong to the same element. Okay, every element in the periodic table has different atomic number. The main ore of chromium is chromite. Chromite contains FeCr2O4. Complete the equation for this reaction. Okay, so we have formed, this is our chromite ore. We added carbon to it. We formed Fe. We form Cr. So what kind of element is left? I guess only one element is left, which is carbon and oxygen, and we're given with one blank, so we're going to form carbon dioxide. We just have to balance it out. How many carbons we have on this side? Okay, we have 2 of this, we have 1 of this, and now we have 4 carbons and 4 oxygens. Oh, that's interesting. I love this question, because now first I'll form carbon dioxide, because I know that's something being formed. But when I try to balance it out, I cannot balance it out. Why I cannot balance it out? Because look, 4 carbons, 4 oxygens. Okay, 4 carbons, 4 oxygens. Over here, if I add a 4, my carbons are balanced, but my oxygens are 8. And I cannot add a number over here. I cannot add a 2 over here to make this oxygen 8. So what will I do? I will not form carbon dioxide. Instead, I will form carbon monoxide. And to balance it out, I write a 4 over here. Okay. I just pull out with a 4 over here. And now this is balanced. Okay. So you just had to do this thing. I hope you get it. You did not have to form carbon dioxide, instead carbon monoxide, because with carbon dioxide you cannot balance the equation. Okay. Suggest one disadvantage of extracting chromium by reacting chromite with carbon. Okay. Your disadvantage is simple. You're forming carbon monoxide. Carbon monoxide, because when you react chromite with carbon, this is your chromite with carbon, carbon monoxide is formed, which is a toxic gas. So you write carbon monoxide because it reacts with the hemoglobin in the blood, and you know that leads to your less transportation of oxygen around the body. So carbon monoxide is formed, which is a toxic gas. Okay. Chromium can be mixed with nickel and other elements to form stainless steel. Okay. Chromium element that's mixed with nickel to form stainless steel. One thing you should know, that what is this stainless steel? This is an alloy. Name the type of substance formed when metal is mixed with other elements. I guess the examiner has just made it the way I'm thinking about it, that it's an alloy and you just had to write alloy over here. That's simple. Okay, now we have a ammonium chromite something kind of thing. Okay, this is a compound containing chromium. Okay, the negative ion in this is Cr2O7 2 negative. Okay, I love this question. You know why? Because before they could tell you that this is 2 negative, can't you reduce it yourself? One ammonium is a +1, and you have 2 ammoniums. That means you have a 2 plus. Okay? And to balance out a 2 plus, this entire thing, Cr2O7, has to have a 2 negative charge. Okay? I guess they didn't have to mention this out. You could figure it out by just looking at it. To balance out this thing needs to have a 2 negative charge. Okay. State the sum of the oxidation numbers, okay, in Cr2O7 2 negative ion. Okay, you have to state the sum of the oxidation number in this ion. The first thing I guess you have to do is that you have to figure out the oxidation numbers. Okay, and just by looking at it, I guess you know that this needs to have, chromium needs to have a 6 plus, but okay, it needs to have a 6 plus. Yeah, one chromium will have a 6 plus charge. How do I figure it out? Well, to understand this, you need to just know that the oxidation numbers, I guess, in a good way. Let me explain it to you. Because look, over here, you just have to realize one thing. One oxygen has of 2 negative. Over here we have 7 oxygens. So 2 negative multiplied by 7 is going to give me a negative 14. Okay. To balance out a negative 14, I need a positive 14. But over here, I have to do this exactly when it was exactly a balanced compound, but it is not. It has a 2 negative charge. That means I have to have 2 more negative things than the positive. That means I need to have 2 more negative charge. That means the positive charge is going to be simply a plus 12. Why a plus 12? Because plus 12 and negative 14 is going to give me a answer of, if I do plus 12 and negative 14, what is going to be my answer? Negative 2. And that is what is the charge on this ion, and that is what I need. So the sum of charges, this is the sum of charges, is going to be negative 2. Okay, the oxidation number in each oxygen, each O in this is 2 negative. Okay, I know this thing. Determine the oxidation number of each chromium in this ion. Okay, I guess that's easy peasy lemon squeezy. That's going to be plus 6. How do I know this? Because just look over here. Total charge on this Cr2 is 12. Okay, plus 12. Okay, and there are 2 chromiums that are having a charge of plus 12. So one chromium, each chromium they've written, each chromium is going to have plus 12 divided by 2, that's 6. Okay, again, if 2 have of plus 12, one's going to have of plus 6. Okay, I hope this was easy. Moving on. Okay, now we have some moles. When this ammonium chromate thing is heated, the following reaction occurs. Okay, we're given with equation in the question, and when we're given with equation in the question, you have to be careful. You have to just look at the moles that are in the equation. Okay, calculate the volume of nitrogen gas produced at RTP in cm cube when 1.26 grams of this ammonium chromate thing is heated using the following steps. Okay, the MR of this is given. Calculate the number of moles used. I guess even if in O-levels question as we're not given with these things, these steps, but still let's just go with the steps. We can do it without the steps as well, but just let's follow the steps. Calculate the number of moles. Okay, that's simple. Moles equals to mass upon MR. So moles equal to mass, which is I guess 1.26 grams. 1.26 upon MR. MR is 252. Okay, so 252. So 1.26 divided by 252. 1.26 divided by 252. That gives me 0.005 moles. Okay, moles come out to be 0.005. Okay, next thing. Determine the number of moles of N2 formed. You see the molar ratio. If 1 mole of this thing forms 1 mole of nitrogen gas, then 0.05 moles of this thing will form 0.05 moles of N2. So the number of moles of N2 are going to be 0.005. Calculate the volume of N2 formed at RTP. Simple. Moles equal to your volume divided by your 24, when it's in cm cube, 24,000 cm cube. Okay, so moles is 0.005, and this 24 comes upon over here, multiplied by 24,000. That's going to give you your volume. So 0.005 multiplied by 24,000 multiplied by, and that gives me 120 cm cube. Okay, so that's 120 cm cube. Done with this thing. Moving on. Alkali metals are reactive elements. Okay, state the group number of alkali metals. Oh, that's so easy. Alkali metals group 1. Is this even a question? That's so easy. That these are free marks. Identify the alkali metal which has the highest melting point, has the highest density, has the lowest reactivity, burns in a lilac flame, is found in fertilizer to improve plant growth. Lilac flame, potassium. Okay, that's easy. I guess you should all know the flame colors by heart: sodium yellow, lithium red, potassium lilac, all other barium light green, and then you have barium, and then you have copper, which is blue green. Just learn all of them. Is found in fertilizers to improve plant growth. Alkali metal. You cannot write nitrogen, you cannot write potassium. You can write potassium, but you cannot write phosphorus. So the fertilizers that we use are NPK: nitrogen, phosphorus, and potassium. So it's gonna be potassium, because that's the only alkali metal. Other are phosphorus and nitrogen. Has the lowest reactivity. So you should know that the reactivity of alkali metals, if I have a picture of periodic table, let me show it to you guys. So look, this is the periodic table, and in your periodic table you know that the reactivity increases of alkali metals, it increases down the group. So the least reactive is going to be your top alkali metal. Okay, so these are your alkali metals. Okay, this is your group 1. Reactivity increases down the group. Okay, so this Fr francium thing is going to be the most reactive, hence the least reactive is going to be your lithium. That's going to be at the top. So has the lowest reactivity, it's going to be lithium. Has the highest density. I guess you should know the trends. Your density increases down the group. Okay, the density increases down the group. So the most dense is going to be this francium. So francium has the highest density, has the highest melting point. Okay, you should know this, that your melting point basically decreases down the group. Your melting and boiling point decreases down the group. So your highest melting point is going to be of your lithium. Okay, and just let's see it from here. Okay, so you just had to know all of this together. This is the exact exam paper that I've copied. So you just had to know all this, and you could just write the symbols as well. You could write the full form, but I guess it's better if you write the symbols, because for some you might not even know the spellings as well, especially francium. Okay, so I guess that was all. Moving on. Sodium sulfide Na2S is an ionic compound. Okay, complete figure 5.1 to show the electronic configurations of the ions in sodium sulfide. Show the charges on the ions. I guess that's easy, because you know that sodium, it's simply going to have a charge of a +1 because it's an alkali metal. So sodium is going to have +1. To balance out a +1 charge, you need a 2 negative charge. +1 means that basically you've just lost your 1 electron and your last shell is filled. Okay, you just need to have a complete last shell. They're going to be 1, 2, 3, 4, 5, 6, 7, 8 electrons. And over here as well, you're going to have 1, 2, 3, 4, 5, 6, 7, 8 electrons. 2 negative as well means whenever you have ions, you're going to have full shells. Okay, ion means that you have full shells. In O-levels, not talking about A-levels, in O-levels, ions are going to mean that you have full shell. So both your sodium ions and your sulfide ions, both are going to have full shell. So over here 1, 2, 3, 4, 5, 6, and the trick comes here, because this is S 2 negative, that means it has gained 2 electrons, one from each sodium it has gained. So these 2 electrons are going to be circles, not crosses, because cross means a this sulfur electron, but we have just gained 2 electrons from sodium, so they're going to be 2 dots. Okay, you just had to be careful about this. Moving on. Rubidium has only 2 naturally occurring, naturally killing atoms. Rubidium 85 and Rubidium 87 state the term given to these naturally occurring atoms of rubidium. You should know that Rubidium 85 and Rubidium 87 are going to be isotopes of each other. So I guess that is simple, unless someone confuses isotopes and isomers and write isomers over here. I know sometimes in confusion we just confuse these two words, but these two are isotopes of each other. Okay, moving on. we have to fill this table, and we just have to write the number of protons, neutrons, and electrons. So protons, they're going to be same for 85 and 87 as well. Why are they going to be same? Because remember that the proton number does not change in isotopes. Okay, so you just have to consult a periodic table. Whereas rubidium is in group 1. This above 1 is your proton number. This is your proton plus your neutron number. This is your basically mass number. So both is 37. Okay, so we just have to write 37 over here. So protons 37, 37, electrons 37, 37, because we don't have any ions. And to figure out the neutron number, we just have to minus 37 and this 85. So 85 minus 37. 85 minus 37, that gives me 48. So neutrons over here, they're going to be 48, and because they're two more, so they're going to be 48, 49, 50 over here. Okay, I guess that was simple enough. The relative atomic mass of rubidium to one decimal place is this. Determine the relative abundance of 85 Rb in rubidium. Express your answer as a percentage. Okay, try to understand this thing that I'm going to explain you right now. I don't know if you get this thing or not. If you simply use the formula, okay, if you use the formula, that's going to be the atomic number, not the atomic number, the mass number, which is 85, upon the sum of total abundance, which is going to obviously going to be 100. 85 multiplied by x. Okay, 85 is going to be more, so 85 multiplied by x plus 85 multiplied by 100 minus x, because obviously if one abundance is x, okay, if one abundance is x, the other abundance has to be a 100 minus x, because the total abundance I've taken is 100, is going to give me 85.5. okay, let's solve it. That is a one way of doing it. I'm going to show you another way as well, inshallah. That is just one way of doing this question. Okay, which okay, so we put a 0.5 over here. That's gonna make 85x plus that's gonna give me 8500 minus 85x equals to 85.5. 85x plus 8500. I don't know if this method's gonna give me, because this gets over here, gets multiplied. They're gonna move it 2 decimal. This gives me this thing, I guess. This thing and this thing cut out, and now it's just 8500 equals to, how do I get the value of x over here? I guess this method is not meant for me. I can just do it mentally. I don't need this method as well. I just told you it's a 1 mark question. I can do it mentally, simply. How do I do it mentally? I'm gonna show the way I use it mentally. I was just trying to do the formula for you guys, but mentally it's 85. The other one's 87, and between 85 and 87 you have 86, and just divide it into blocks kind of thing, something like this. 2 blocks over here, 2 blocks over here, and in between you have 2 blocks, something like this, I guess. This is 85.5. This, no, a second, yeah, this is 85.5. Then you get 86. This is 86.5. okay, now this is exact center. Okay, this is exact center. This 86 is exact center. I do it this way. I know it's a bit messy, but just try to think about it in this way. 86 is exact center. Over here you have 50%, over here you have 50%. okay, if you move a bit, because your abundance is 85.5, it is not 50%. okay, it is not 50%, it is more towards this side. So that means that your percentage abundance of this 85 is going to be 75%. Why 75%? Because look, it's more towards 85. The abundance I don't know how to do it by formula. I just do it mentally. Always I do it mentally, something like this. Because the abundance, that's going to be the answer. देखिए 85.5 हमारी is your atomic number, okay? Is the atomic mass, okay? So the abundance is going to be more near, okay? It's going to be more near to the thing that's more in abundance, okay? You have 185 and you have 187, okay? And now your atomic mass is coming out to be 85.5. Is 85.5 more near to 87 or 85? Obviously it's more near to 85. That means that 85 is more in abundance. But how much more near is it? If you do half, you get 86. Okay, you get 86. That means 50% over here. Half means and 50% of this thing. But now it's not half. It's this. Over here comes 85.5. So that means that this thing is in 75%. I know you guys might not get it. I don't know how to make you guys get it, because you guys might do it with formula, but I just do it with this logic. I guess that's a good logic. Why is this a good logic? Because if you use this formula, okay, I don't know what is this formula, I've never used it. You do it with this formula, I hope you get the right answer, but I do it with simple logic, that the more your abundance is near a number, the more you have that of that thing. I know you guys don't get it with me, but just let's leave it over here. You just have to understand one thing, that because this answer is more near 85 than 87, then the abundance is going to be more of 85. 85 is going to be 75% in abundance. If your maths is good, you can just do it mentally easily, okay? I just don't do any working over here because I did it just mentally. Okay, so question number 6, which says ethene C2H4 is the first member of a family of similar compounds which contain the alkene functional group. Okay, state the term for the family of similar compounds which contain the same functional group. Okay, similar compounds which have the same functional group. Homologous series or homologous compounds, you can call them. Determine the difference in relative atomic mass between ethene and the next member. Okay, we have to tell the difference in the relative atomic mass. The difference is of one methyl unit, which is CH4. This is one methyl unit, okay? CH2, sorry, not CH4, CH2. This is one methyl unit, okay? You call this one methyl unit. So it is, carbon is, I guess, 12, 13, 14. So it's going to be 14, because look, if you look over here as well, one methyl unit is CH2, and the mass that you get for one methyl unit is going to be 14, okay? So the next question says, write the simple equation for the complete combustion of C2H4, which is ethene, okay? You should know that this one's ethene. I guess that's simple, needs no explanation. C2H4, general formula is CnH2n, which means it is an alkene, and since it has two carbons, it's obviously going to be ethene. So if you write a simple equation, simple means that you cannot write carbon dioxide, you have to write CO2, you cannot write water, you have to write H2O, and you have to use simple equation for the complete combustion. Complete combustion means that you cannot form carbon monoxide, you have to form carbon dioxide. So let's get going. First, we're going to have C2H4, and we have to completely combust it, so we need oxygen for it, and for complete combustion, the products are going to be carbon dioxide and your water. Okay, so now just we have to balance it. Since we have two carbons on this side, we're going to put A2 over here. We have 4 hydrogens, we're going to put A2 over here. How many oxygens we have? 2 times 4 plus 2, which is going to make it 6. We put A3 over here. I guess we're done. Okay, C2H4 reacts with steam to form ethanol. Okay, that's what we know. And the conditions for the reaction are 300 degrees Celsius temperature, 60 atmospheric pressure, and H3PO4 as catalyst. Okay, the process happens in a closed system and the reaction reaches equilibrium. Equilibrium means the rate of the forward reaction equals to the rate of the backward reaction. This never means people usually confuse equilibrium with rate. It has nothing to do with the rate. Okay, equilibrium is a completely different thing, and equilibrium does not mean that the products on the reactants on this side and the products on this side are equal. No, it just means that the rate or the speed at which the products are converting into reactants, at the same speed the reactants are converting into the products. Not the amount of them are same or something to do with the amount. It's with the speed. Okay, the conditions require this, and this. Okay, complete table 6.1 to show the effect, if any, on the concentration of C2H4 when the following changes to the conditions are applied. Only use the word increases, decreases, or no change. Okay, I guess that's simple enough that we just have to figure out what's going to happen to the amount or the concentration of our C2H4. Okay, so our main goal is to be careful about what happens to this thing. Okay, what happens to this thing. And now, one thing that I believe that you guys should be very well aware of is that we're using a gas, and we're using a gas, okay? And you guys should be well aware of the fact that when we're using gases, the pressure also affects the equilibrium position, okay? So let's get started. Only use the word, okay? Table 6.1 changes to the condition. Temperature is decreased, okay? Effect on the concentration of C2H4 at equilibrium. We are decreasing the temperature. Temperature is decreased, okay? Whenever we decrease temperature, okay, you just have to know one thing, that since this is exothermic, so the forward reaction is going to be exo. And when you know that the forward reaction is exo, you should automatically think that the backward reaction is going to be endo. Okay, now you should know one thing, that whatever we do to the equilibrium is going to try to reverse it. Okay, so what we're doing is that we're decreasing the temperature. Okay, we're decreasing the temperature, and when we will decrease temperature, what will equilibrium do? Equilibrium will try to increase it, and when equilibrium is going to increase the temperature, what will it do? What do I do to produce heat? I need to produce heat. I'll do an exothermic reaction, because exothermic reactions release heat to the environment. So when the temperature is decreased, we decrease it. Equilibrium, in order to increase the temperature, to reverse what you have done, it's going to increase into the exo part. So that means that the equilibrium is going to shift forward. And when the equilibrium moves forward, what's going to happen? Our C2H4 is going to decrease. Why it's going to decrease? Because this thing, this C2H4 and H2, is going to be converted more into ethanol. So when we decrease the temperature in order to increase it, equilibrium moves forward. And when equilibrium moves forward, what's going to happen is that this thing decreases. So we have to use the word decreases over here, I guess. So this is decreases. Okay, next one. Some C2H5OH is removed. Okay, so what you're doing is you're removing this thing. Okay, I just told you, remember one thing. Whatever we are doing, equilibrium is trying to reverse it, to do the opposite. Okay, so when we are trying to decrease this, okay, because we are removing it, okay, we have decreased this in order to increase it, what will equilibrium do? Equilibrium will produce more of it. So equilibrium will move forward in order to produce more of this thing, because we have removed it. So when equilibrium will move forward, this C2H4 is going to be utilized or used. Okay, so this will again decrease. Why? Because equilibrium is moving forward. So again, our concentration of C2H4 decreases. Okay, pressure is increased. Okay, let's see. When we're dealing with pressure, we have to look at the moles of the gases. Okay, so we have 1 mole of gas of C2H4, we have 1 mole of our H2O, and we have our 1 mole of ethanol, and all of them are gases. Okay, so this means a total on this side, how many moles we have? We have a total of 2 moles of gases on this side and 1 mole of gases on this side. Okay, that's, I guess that's not debatable, that's pretty obvious, but we can see. Okay, next thing, pressure is increased. Increasing pressure shifts the equilibrium towards the side that has less moles. Okay, increasing pressure, whenever you're increasing pressure, the equilibrium will move towards the side that has less moles, and when you're decreasing pressure, equilibrium move towards the side that has more moles. Right now, since you have increased the temperature, so equilibrium will move forward towards the side that has less moles. When equilibrium will move forward, what will happen? More of this will be used. So the concentration of C2H4 in the equilibrium again decreases when we increase pressure. Okay, So again, this one's going to be decreases. Okay. Next one. As more effective catalyst is used, a more effective catalyst is used. Okay. I'd like to tell you guys one thing, that catalyst basically does not affect the concentration of any substance. It does not affect. What catalyst does it increases the rate. But a catalyst cannot affect the position of the equilibrium, the concentration of the reactants or the products. Catalyst cannot do all this. Only the thing that a catalyst can do is that it can speed up. And when a catalyst is added, tell me one thing, okay? This is like a bit A-levels oriented, but still, tell me one thing, that whenever I add catalyst to anything, what will happen? Will it only increase the rate of the forward, or both the forward and the backward? Always remember, a catalyst does not only increase the rate of forward reaction. Many people think that it increases the rate of forward. No, both the forward and the backward reaction happen more faster. So thinking logically, the concentration of any single thing does not change by adding a catalyst, nor does the position change. Only everything happens faster. Okay? It just happens faster. Just think that you're making a time lapse. A catalyst is just a time lapse. You know, when you're using your camera, sometimes you just make a video, sometimes you make a time lapse. Whenever you make a time lapse, everything happens faster. But it does not, that some scenes skip. No, nothing skips. It just happens faster. So what a catalyst doing, it's increasing the speed of the things. It's not skipping some parts or doing anything else. Okay? So it's simply going to be no change. For the catalyst, it's going to be no change. Okay, explain in terms of the collision theory why the rate of the forward reaction increases if the temperature increases. Okay, you have to explain in terms of collision theory why forward reaction increases. Why? Because what you're doing is that firstly you're increasing the kinetic energy, and the second thing you're doing is you are basically providing more particles with energy equal to or greater than activation energy. So that means that more effective collision. So the first mark is going to be that the kinetic energy of particles increases. And the second thing is going to be that more particles possess energy equal to, this is an important line in order to gain these 3 marks. This is a very important line which many people forget. More particles have energy equal to or greater than activation energy. Equal to, because you need the activation energy in order to react, in order to collide with enough energy that you can make the product. Okay, sometimes there are collisions, but product is not formed. It's not that every time 2 reactants would collide and product will form. No, only if the reactants, they collide with enough energy that is equal to or greater than the activation energy, only then the product is going to be formed. So more particles have energy equal to or greater than activation energy. Hence, this is the first mark, this is the second mark, and this one's the third mark. Hence, the frequency of effective collisions increases. Okay? Effective collisions are very important. Not all collisions are effective. Only if your collision is effective, then your product is formed. Okay. Compound B has the displayed formula shown in figure 6.1. Okay, reduce the molecular formula of compound B. Molecular formula is very simple. You just have to count everything. So let's get started with counting our carbons. So 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon. I guess we have 5 carbons. I don't see any more. So it's going to be C5. Now let's count oxygens. 1 oxygen, 2 oxygen, 3 oxygen, and 4 oxygens. So we have 1, 2, 3, 4 oxygens. Do I see any more oxygens? No. So C5O4. And H, let's count them. 1, 2, 3, 4, 5, 6. Do I see any more? 1, 2, 3, 4, 5, 6. No. So it's going to be H6. So C5O4 and H6. Done with this thing, moving on. State why compound B is unsaturated. Okay, that's a very good question, and I know many people will think that, firstly, everyone knows that unsaturated means a carbon-carbon double bond as shown. But some people might think that there's a double bond over here as well and here as well. So this might be unsaturated because of carbon-oxygen double bond, but that's incorrect. No matter there's a carbon-oxygen double bond, fluorine double bond, or any kind of double bond, only unsaturation can happen because of carbon and carbon double bond. When two carbon atoms have a double bond, that's when you say that something is unsaturated. All these other double bonds, they don't matter. I know many people think that this is also unsaturation, this is also unsaturation. Unsaturation in this compound is only because of this. You know why carboxylic acids, for example, if I draw ethanoic acid, which is something like this, I guess. Okay, this is your ethanoic acid, okay? And this is saturated. Why this is saturated? There's a double bond over here. There's a carbon-oxygen double bond. Then why it is saturated? Because there's not a carbon-carbon double bond. Unsaturation can only happen when you have a carbon-carbon double bond. This is completely saturated, though it has a double bond. But that's not a carbon-carbon double bond. That's a carbon-oxygen double bond. So you have to think about these things, okay? So state why compound B is unsaturated. It has a carbon-carbon double bond. Okay? So let's move on. Draw the structure of one repeat unit of a polymer formed when compound and B undergoes addition polymerization. Okay, that's a very, very good question, and it's of 2 marks. We just have to draw one repeat unit. So let's get started. How will addition polymerization occur in it? First thing to think about. Always remember, addition polymerization will occur at this point. This is our main focus. We have to focus on this thing. That's what I want in the center, and all these distractions, this all thing, I want at the sides, okay, in a complete form. So let's just draw it in a way that's in the, I just call it a proper way or proper simplified unit, okay? So we have a carbon-carbon double bond in the center. Above this carbon, I have this thing, which I can say COOH, okay? There's one C, there are 2 O's and H. So above I have COO and H, okay? And below this carbon I'm talking about, above I have COOH, which I've written, and below I have one hydrogen. So I draw one hydrogen like this, okay? Now I talk about this carbon, okay? Above I have CH3. I just draw like this, and wait. What I have to do is create some space like this, okay? Above I have CH3, something like this, and below I have this thing, okay? This thing, which is again COOH, so COOH. So that's my simplified version. Now, since I have to draw a structure of one repeat unit of the polymer formed, I just have to draw this same thing below. I just have to remove this double bond and draw the extension bonds, okay? Either you can draw this thing as well, but I prefer if you just draw the full version, okay? But I believe it's going to be a bit difficult to draw each and everything. So what we do is we just draw this thing, okay, with the extension bonds. So there's going to be one carbon, something like this. Don't draw this double bond because this is the repeat unit of an addition polymer. Something like this. These are the extension bonds. Above we have COOH. Over here we have CH3. Over here we have COOH. And we have a hydrogen like this. So this is one repeat unit, which is this thing. Okay, I guess this was simple enough, easy enough to digest. Don't forget these extension bonds. If you just do this, you write a N over here, it's fine. I don't think that's something to worry about. Just you have to make sure these extension bonds are there. Okay. Explain why 1 mole of compound B reacts with 2 moles of sodium hydroxide. Because it has 2 carboxyl groups. Because it has 2 acid groups. Do you get it? So 1 mole of this compound will react with 2 moles of NaOH because it only has one, this alkali part is only 1 in it, okay? If it was something like this, then 1 mole of this compound, this whatever this thing is, of compound B would react with 1 mole of NaOH. Not Na, if it was MgOH2, because now we have 2 of these. But over here we have 2 carboxyl groups and one this hydroxide group. Okay, so why? Because we have in 1 mole of compound B we have 2 moles of this hydrogen thing. क्योंकि यहीं से from here our H plus ions are going to come into the solution. Or carboxylic acid group, functional group you can write, functional group, or you can write it can donate, because acids are proton donors, can donate 2 H plus ions. 1 mole can donate 2 moles of H plus ions. Okay, just simplify it and just tell this thing. Okay, ये देखिए यहाँ से एक H plus आ जाएगा from here and 1 H plus from here. Okay, so the next part says calculate the volume in cm cube of 0.250 mole per dm cube NaOH that reacts with 0.1 mole of compound B. Okay, that might seem tricky, challenging to some people, but it's simple. Look, we know that 1 mole of compound B reacts with 2 moles of sodium hydroxide. So 1 mole of my compound B, CB I'm writing, will react with my 2 moles of my NaOH, and I don't know what product are they going to form. So I just make a space over here. Now what do I know? I know the ratio. I know the ratio in which both of them are reacting, that 1 mole of this compound B is going to react with 2 moles of NaOH. So in this question, I am, given with the concentration of NaOH and the moles of compound B. When I have the moles of compound B, I can easily figure out the moles of NaOH, because I know that my ratio for compound B and NaOH is simply going to be, look, okay, so NaOH ratio compound B, which is Cb, is 2:1, and if I have 0.100 moles of compound B, which is 0.100, I'm going to have X moles of NaOH, and X is going to turn out to be 0.200. Now I have the moles of NaOH. Okay, what do I have to find? I have to find the volume. I simply have the formula which I can use, and this one right here is the formula. Volume equals to my moles upon my concentration. Moles are 0.200 and my concentration is given in the question, which is 0.250. Okay, so 0.200 divided by 0.250, let's do it on the calculator. 0.200 divided by 0.250, and that gives me 0.8. Okay, so my answer comes out to be 0.8, and I write it like this, 0.8. But this is in dm cube, and the question is specified cm cube. In order to convert this dm cube into cm cube, why is this in dm cube? Many people might ask, what was your concentration given in? It was in dm cube. It is in mole per dm cube, and when your concentration is in mole per dm cube, your answer of the volume also comes out to be in dm cube. In order to convert it into cm cube, as the question is specified, what we have to do? We have to multiply this 0.8 with 1000, and I guess that's going to give me 800 cm cube. I move this 1, 2 and 3, so my answer comes out to be 800 cm cube. I hope you got everything in this paper which I've explained, and if you have any confusion, any queries, anything that you don't understand, ask it in the comments below, and I'd be happy to respond. And thanks for watching. Bye bye.